Hello guys, welcome to our channel. Now I'm going to discussing about heter heterocyclic compound, and before going the topic, we should know what is heterocyclic compound. The cyclic compound, the cyclic compound which contain at least one heteroatom. Then we should know about heteroatom. What is heteroatom? The atom other than carbon and hydrogen atom are known as heteroatom. And this is the cyclic compound which contain at least one heteroatom is known as heterocyclic compound. And what is heteroatom? Heteroatom, the atom other than carbon and hydrogen is known as heteroatom. Generally, I will discuss about 5-member and 6-member heterocyclic compound. Then here we'll see some of the example of 5-member and 6-member heterocyclic compound. 5-member. This is Pyro. When the heteroatom is nitrogen, then it is Pyro. And when the heteroatom is oxygen, it is furan. When the heteroatom is sulfur, it is called thiophene. Okay. This one is indole, and these all are aromatic compound because here 2 pi bond 4 electron and also 1 pair of all the compound participate in resonance, and hence total number of electron will be 6, and hence all are aromatic. Then 6-member heterocyclic. Six-member heterocyclic compound. We'll see some of the example. Pyridine. This one is pyridine, and this one is quinoline, and pyridine, isoquinoline. This one is pyridine, this one is quinoline, and this one is isoquinoline. Here generally we will see the preparation and chemical properties of this pyrrole, thiophene, and furan. So we will see the synthesis and chemical properties of pyridine. First, I will discuss about pyrrole. And here I will show structure of pyrrole, and I will show the molecular orbital picture of pyrrole ring. And this is the molecular orbital structure. Here all the carbon p orbital is contributing 1 electron, and also that nitrogen p orbital contributing 2 electron. Hence total number of electron is 6, and the 6 electron constitute aromatic and sextate. Total number of electron is equal to 6, hence aromatic. And then we'll see the resonance structure of pyrrole. Resonance structure here, this is pyrrole. This electron go this way, and then this electron go this way. This electron go this way. Hence then we'll see pyrrole is a weak base. Pyrrole is a weak base as compared to pyridine. Here, see this lone pair is always, this pyrrole nitrogen lone pair is always take part in conjugation with the ring, and here the in case of pyridine there is this lone pair is inert. It is it does not take part in the resonance. Hence hence basicity of this pyridine is more as compared to this pyrrole. That's why pyrrole is less basic as compared to pyridine. Before I have already shown you the orbital structure. The orbital structure. This is the orbital structure of pyrrole, and this is from this orbital structure. It is showing that in this two field, these two electron will take part in resonance, but in case of pyridine, if we draw the orbital structure, we will find it is orthogonal, and this field, these two electron are orthogonal to this the orbital. Hence this orbital, these two electron does not take part in resonance. Less basic. This one is more basic. Then we will see synthesis of pyrrole. Generally, we will see the synthesis by three important name reaction, that is Polymer synthesis, Polymer synthesis, and another is NOR pyrrole synthesis, and another last one is hard synthesis. So we'll see what is Polymer synthesis. Generally, Polymer synthesis by treating what is Polymer synthesis? By treating 1,4-diketone with ammonia or primary amine. We'll see 1,4-diketone. This is R1. This is R2. This is 1,4-diketone because then we will treat with primary amine or ammonia. It will give the spiral. Then we will say the mechanism of polymer synthesis. First, we will take this diketone. R2 with NH2R. This will attack here. This is R2, NH and R. This electron will go this way and this will go this way. This is positive and this will go this way and this electron will go this way. And R, then the carbonyl. Again, this nitrogen lone pair attack to the carbonyl. Then we'll treat with acid and it will give this will attack here. This electron will go this way. And this, when you treat with acid, it will attack to the when we heat it, this OH2 will go away and it will give like this R2 R1 when we treat with, and this electron will go this way and this electron will go this way. The product. This is the product. Then we will see nor-pyral synthesis. It involves the condensation between an alpha amino ketone and a beta diketone, which produce derivative of pyrrole. See here, it involves the condensation between an alpha amino ketone and a beta diketone or ketoester, which produce a derivative of pyrrole. Here, this is the alpha amino ketone. This is the alpha amino ketone, and this is the beta diketoester, and it gives this pyrrole derivative. Then we will see the mechanism of this reaction, nor-pyral synthesis. Then we will see the mechanism of nor-pyral synthesis. This one is the alpha amino ketoester. When it will treat with this molecule, here see, here is two center, one is keto center and one is ester carbonyl. Hence this lone pair preferably attack to the keto carbonyl group but not to that ester carbonyl group, because we know the keto carbonyl carbon is more reactive as compared to that ester carbonyl carbon. Hence this lone pair will attack to here, and we'll see that this one and this one is CH3 and this one is OH and this one is CH2. Hence again this is acidic proton, this one is acidic proton. Hence we'll see here when it will come back, it will go this away. Again this will go this way, again this will go this way. and here it is positive, and so this proton will go this way. And here is the one proton, it will go this way and this way, this way. Finally here it will be double bond. Sorry, here is CH3. Oh, it is, sorry, 8. All about those mechanism of non-pyral synthesis. Then we will see about Hunt's synthesis. In Hunt's synthesis, the condensation between chloroacetate and a beta ketoester and with a primary amine. Just we will see this one. And this is ammonia, and this is chloroacetone. Will give this product. And we will see the mechanism, whole mechanism. First is ketoester will attack by ammonia. It will give like this product. And when we heat it, it will eliminate water molecule. Then again it will attack to this chloroacetate. This will attack here. And this one will go this way, and this NH will attack to the carbonyl. When we heat it, water will be eliminated. And finally, it will give this product. And this was all about the synthesis of Pyro of different reaction like hand synthesis, polymer synthesis, and nor Pyro synthesis.